represents the difference in price elasticity of demand between grocery stores and liquor stores. And that makes sense. We've done dummies enough time to know that. Beta 1 was the price elasticity of demand at grocery stores. Beta 1 plus 4 is the price elasticity of demand at drugstores. So beta 4 represents the difference in the price elasticity of demand between drugstores and grocery stores. And we expect beta 4 to be negative because we expect the price elasticity of demand to be more negative or more sensitive. Okay. There we go. And for liquor stores, it's going to be beta 1 plus beta 5. Where beta 1 plus beta 5 is the price elasticity of demand for wine at liquor stores. Beta 5 represents the difference in the price elasticity of demand at liquor stores relative to grocery stores. All right. And we expect beta 5 to be positive because it'll be a positive added to a negative, so the number will get smaller, which means, the number will get closer to 0, which means consumers are less price sensitive at liquor stores. Let's ignore all this stuff. These are our results. Okay. That is not good. But we can last. We know we can. Let's go to Stata. All right. Are we 11 or 12? I think everything's formatted already. I'm not sure what the largest data set we've had is, but this one is 632,000 observations. Remember, we got 44 periods, we got multiple SKUs, and we got across 3 different channels. So I've trimmed it down as much as we can, but it's a relatively large data set. All right, so let's kind of cut to the chase. That first, basically, market is, if we tab market, it tells us whether we're food, drug, or liquor. So basically what I did was I tab gen'd it. So tab gen market, that creates 3 variables, one for market 1. Market 1 is, let's do this. Market 1 is drug, market 2 is food, market 3 is liquor. And then I just renamed those food, drug, and liquor. I am going to do this. This is just the table of our price differences. All right, so there's our price differences. We know that if we run a regression, that simple dummy variable regression, it should give us, perfect, it should give us, so average price at drugstores, $11. Average price at grocery stores, average price at drugstores, $8.11. Average price at grocery stores, $11.77. Average price at liquor stores, $13. Remember, the constant is our omitted category, which is grocery stores, $11.77, which is the same there. Liquor store is $1.40. Liquor stores are on average $1.44 more, and that difference is statistically significant. Drugstores are on average $3.66 less per bottle, and that difference again is statistically significant. But remember, these results are subject to sample selection bias because it's not the same sample of wines that's sold across all 3 channels. So what I had to do, actually I didn't do it, my research assistant did it because they were better at writing code than I was. I had to write a code that basically tagged the wines and identified a wine that was sold across all 3 channels. And that tag is the subsample that we need to use. Now, I'm not going to have you run the code, but I already ran it, and it's in the data set. It's actually a pretty cool code. You should see it. If we had a little bit more juice on the computer. Let's see. Subsample 1. Okay. And I think we're only going to work on subsample 1. In fact, I'm almost certain of it. So to get subsample 1, this code thingy, this file, it's a loop that goes through all whatever millions of observations I have. It creates this M1 total if you're in market 1, M2 total if you're in market 2, and M3 total if you're in market 3. Now, set M1 totally greater than 0, and M2 total greater than 0, and M3 total greater than 0. That identifies only wines that are sold across all 3 markets. And perhaps we got 7%. That's plenty. That'll last us an hour. I don't think you need to set price greater than 0 in cases greater than 0 and 750 greater and 750 because I think the data set already has all those things set. I think I dropped everything. The data set was getting big, so I think I dropped those out already. Those are left in there just as a residual from when they were in there. But given that we've done that, again, the magnitude of the price differences are smaller, but the direction of the price differences are the same. Drugstores are still the cheapest, followed by grocery stores, and then liquor stores are still the most expensive. We're going to generate some box plots and all that kind of stuff, which we've already done. Box plots. So let's do a box. It's thinking, it's doing the math.
So we're not going to need to put the and size 700 at all. We should only have to do the M1 total.
I don't think so. What you can do is, here, what we can do is this. So here's a nice thing. I think if I tab size, so you do, so 750, so there are other than 750s in there. But I think if I sum price, yeah, prices are always positive, although sometimes in the data set you can get negative prices, basically data anomalies. And if I sum cases, I think it's only, yeah, we got positive cases. So cases and, so what you can do, if you want to trim this down, you can drop everything that's not 750. Because what we want is comparable wines, right? So we don't want to compare a 750 with a 1.5 and say, well, the 1.5 is more expensive. Duh, there's twice as much wine in there. That's not price discrimination. That's buying more wine more expensive. So by keeping everything constant at 1.5, we're able to compare our price differentials apples to apples as opposed to apples and oranges. All right. Log prices, yeah, we can do all that stuff. So take log prices, and let's run a regression. We're going to run a regression in like 5 minutes. So here's a regression on log prices. And log prices are nice because now we have, again, the constant doesn't mean anything. It's the log of something. But what we do interpret is that drugstore prices are about 8% less. And that difference is statistically significant. Liquor store prices are about 4% more, and that difference is statistically significant. So the nice thing about logs is we can interpret those as percentages, and now we can see, 8% versus 4%. We can, what else? I guess check the price elasticities. We can run that price elasticity regression. So, cases, ooh, income's in this data set. That's awesome. And we got some interactions. Drugs, liquor store. All right, so what we're looking at is we can pretty much ignore all the monthly stuff. But if we're looking at price elasticities, we know that the omitted category, so if we set drug equal to 0 and liquor equal to 0, then these two interactions are also going to be equal to 0. So that the coefficient on log price is going to represent the price elasticity of demand at grocery stores.
Where was grocery stores in the previous model?
It was left out. It was left out of the.
It's always the omitted category. So everything's always relative to grocery stores. It's left out here too. Okay, so if we analyze drugstores, then this is, what was it, beta, it's the coefficient on log price. And remember, these are dummies, so these aren't elasticities, but the interaction here represents the difference in the price elasticity at drugstores relative to grocery stores. And that's that coefficient here, which is the interaction between log and